We have Kai Gray, topic of understanding AI, and then we'll follow at 4 p.m. with our keynote speaker, Greta Blash, who will discuss hybrid project management, best of both worlds. So guys, I'm not going to take up too much of your time here. Kai, I want to go ahead and thank you in advance. I know we have a question that's been packed in. Are you Kai, make sure that he is seen and heard?
Yes. Can you hear me okay?
Awesome. Yes, we can. George is still sharing the screen.
What's that?
George is still on the screen.
Oh, yes.
All right. And it is all yours, Kai.
Excellent. Well, first off, before I share my screen, I just want to say thank you very much for having me. It's an honor to be here. I'm excited to talk to everyone about AI. Just a little bit of background about myself. I'm a software developer. I currently, as a hobby, I run the Lower Alabama AI Meetup group. We meet in Fairhope twice a month and in Mobile once a month. And so anyone who's interested and is in our neck of the woods, we'd welcome you. It's a free event. It happens at 3:30, from 3:30 to 5 in downtown Fairhope. Just feel free to contact me. I put my email address in my name here. So so today the goal is really to talk about sort of foundational AI things. So the goal is to not be too technical, but I want everyone to come away with sort of an understanding of what happens when we use AI, sort of what's going on in the background, how does it actually work, so we're aware of that as we sort of progress forward and use AI. These are the building blocks, and I think you've already heard about some AI today. Sounds like the next meetup or the next chapter meeting is going to be focused on AI, which is great. I think the more exposure people get to AI, the better. It's coming whether we want it or not, so it's better to be prepared and to understand it. So with that, let me jump into my presentation. So understanding AI and its impact on the economy. So let's get started. I hope you all can hear this.
Hello and welcome to everyone at the PMI Emerald Coast, Florida Annual Symposium. I'm delighted to be here today to share my knowledge of artificial intelligence. I am a digital avatar of Kai. I am not real. I only look and sound real. The real Kai, standing in front of you now, has never spoken these words. These words were created by AI, fed to me, the AI version of Kai. Today we're going to discuss the evolution of AI to get a better understanding of how AI works. We'll then turn our attention to the economics of AI. Enjoy. Now back to you, Kai, the real Kai.
So that was
hello and welcome.
No, we're not going to. That was a AI generated bot. Some would call that a deep fake, but that was, like the video said, and I hope everyone could hear it, that was a model that was trained on my voice. It was trained on my video. So in some ways it was me, but I didn't actually say any of those words. That was a script that I had typed in. I fed it. I rendered that. And so what I want to talk about is sort of, how did we get to that point? How is it possible that we're able to do something like that? And for those that are curious, that fools my parents. I can send them videos, and my mother refuses to believe that that's not really me. As she said, she's like, I know my child when I see him, and she is wrong. So anyway, we're going to talk about the history of AI. We're going to get into something called neural networks and how they work. Something called transformers, which is really the power behind AI, the one that we use. Large language models, and then talk a little bit about ChatGPT, the sort of the dominant consumer AI platform right now. We'll skip over Alabama's industries, but we'll talk about the economic impact on local businesses, and then a little bit about what's next. So in the beginning, one thing I like to stress is that AI has been around for a long time. So while we're just experiencing it really over the past few years, AI is something that's been in the works, dating back to actually the 1920s. But my timeline picks up in the 1930s, when people were really sort of computers were coming on, were being developed for really the first time to do, actual computational work. And then in the 1950s was when artificial intelligence was coined at something called the Dartmouth Conference, which was a computing conference at Dartmouth University when someone came up with this idea of artificial intelligence. So, for the 50s and 60s, there was actually a lot of talk of artificial intelligence, and then we had this, in the 70s, the idea was that AI was really going to power the military thinking. A lot of military tools will come out of it. And then there was the 1970s saw the AI winter, where if you think of the Gartner's hype cycle, this is effectively what happened. There was a lot of hype in the beginning. It didn't deliver sort of this promise of artificial intelligence, and so the funding basically went away. And that really, from the 70s through the 90s, there wasn't a lot of investment in AI. In the 1990s and the 2000s, that's when this idea of big data, which we're all familiar with now, and machine learning really came into play, and we were starting to amass massive amounts of data through different channels, and so machine learning became this thing. We now have this corpus of data that machines could learn things on, and so then we had this notion of machine learning, which is really the most AI that we use today is really sort of machine learning. The background to this slide is Alan Turing. So if you don't know, sort of Alan Turing was the person that came up with what we now call the Turing test, which is can you make a technology that's indistinguishable from a human, right? So can a computer fool another human into believing that it's a human? And this has always been the test for to gauge artificial intelligence. And most interestingly, over the past couple of weeks, even so, very, very recently, AI has figured out how to defeat CAPTCHA, those sort of the web tools that say I'm not a robot. Well, it turns out that AI can now fool those into believing that it's a human. So some would argue that it has successfully passed the Turing test. Others would argue that there's a lot more to that, but we're definitely going down that track. So in the 20s and 2010s, we had sort of a lot of these deep learning breakthroughs. So one thing that's very relevant right now is Jeff Hinton, who is considered to be the godfather of AI, and the person to really popularize this idea of deep learning. He just won a Nobel Prize earlier this week. That's he's very much in the news right now. And then in the 2010s and really the latter part of 2010s, we had generative models. And so we're going to talk about these. The very first ones were these GANs, the generative adversarial networks. And today what we use is a GPT, but very similar. And then in 2021, 2022, we were all introduced to ChatGPT, which was a generative pre-trained transformer model, and that's the GPT. And we're going to get into how that works. There's Jeff Hinton right there. So a neural network. So a neural network is basically a set of algorithms that's modeled on human brain activity. And so it's really designed to recognize patterns. So if you feed it a number of words or a number of letters, things like that, it can start to remember patterns and learn from those patterns, which is very important for what we do. Neural networks are separated into these layers. So you have an input layer, you have something in the middle called a hidden layer. It's actually called the hidden layer. And then you have an output layer. And so, we're very familiar with this. This works very similar to our ears and our mouth and our eyes. We have input, we have output. And the hidden layer in the human context would be our brain. Um, so the way neural networks are trained, and this is how it's been, this is sort of from the dawn of machine learning, was that you feed it lots of training data. And so the P in GPT is the P stands for pre-trained. And so if you train it with enough data, it can learn how to predict what the next thing is. And so we'll get into that. And that's really where a transformer comes in. So transformers are the things that actually give us what we want, right? So a very good example, and I was recently at an AI conference, and the head of Google's AI was presenting, and he had a very good way of describing this, and I'm gonna share that, which is this idea that if I say, if you're happy and you know it, ... what's the next line? Most people would say, clap your hands. And so we're predicting that. So if I say, if you're happy and you know it, your brain instantly fills in the rest, right? It's doing the transformation. It's taking the first sentence and figuring out what the second sentence is going to be. And that's exactly what transformers do. And so you input, transformers are made up of these two sort of building blocks. You have encoders on one side and you have decoders on the other. So the encoders take in the actual input, and the decoder figures out what that input means, right? And so rather than a translation, think of a transformation, right? This is a transformer. So if I input something that says, that's the pot calling the kettle black, and I ask it to decode that and transform it. Let's say I want to transform that into another language. It could produce the literal translation of a pot calling a kettle black, which may make no sense in other languages, but it could transform it into something that captures the sentiment, right? So what the encoder does is it takes in the literal text, and the decoder figures out what makes the most sense here. Is this person really talking about a black pot and a kettle, or are they trying to make a point about something? What's the sentiment behind that? And that's really what the decoder does. So in your GPT, and so when you type something into ChatGPT, the input is you typing something, and it goes into the neural network. It's been trained on all of humanity's data, and then it figures out through this transformer mechanism what the output should be, what you're trying to get at. And that's what we think of as being in context, right? So it has this idea, if you give it some background, it will answer you back in a context that's appropriate. And that's really the transformer at work. So that all brings us up to large language models. So large language models, and we're probably a lot of us are familiar with them, and we see LLMs a lot, the acronym. So a large language model is basically the series of building blocks. So within the domain of artificial intelligence, there are a lot of different models. There are models for engineering, there's models for math, there's models for vision, speech, and all sorts of different models. Large language models are just one type. And that's the type that we're most familiar with and the one that we use. And it's really this building block, right? So at the foundation, you have neural networks, this sort of the learning process in the brain of AI, so to speak. On top of that, you have the transformer model that is specialized. And then you have a large language model, which just simply means that the model has been trained on language. And so in the early days of ChatGPT and all large language models, it would routinely get things wrong. It would routinely get math problems wrong because it wasn't trained on math. It knew about math because it had read it in books, but it wasn't specifically trained for math. It was trained on language. It was very good. And so, again, if you think of what it's doing, if I feed this model if you're happy and you know it, clap your hands. If I keep feeding it and training it and say, what happens, what comes after the word if, it'll say, oh, I know this one. The next word is your. If your, and I say, well, okay, what's the third word? So happy, because it's been trained on that. So it's predicting what the next word is going to be. And it does that. It's a very simplistic sort of view of it, but it's illustrative of like exactly what happens at a massive scale with trillions of pieces of data, where it's constantly trying to predict what the next right thing is. And so when ChatGPT or Claude or Gemini or Grok or whatever your choice of LLM is, what you're really getting back is a series of predictions. So if you say, how are you doing? It knows, it understands the context, and it will predict that what the next letter will be and what the next word will be. So that's a large language model. And that's what we're all on a day-to-day basis when we're working with AI, particularly the agents that I mentioned, Gemini and Grok and Claude and ChatGPT. We're working with large language models, and that's why they're so good at writing emails and writing letters and things like that. And they may not be great at drawing things. We go to other models when we want images. We go to Midjourney, or we go to Flux, or we go to DALL-E. These are things that have been trained on images, not on language per se. So this is sort of the foundational piece of this, right? So we have we have generative pre-trained transformers. So the G is this idea that we have this ability to generate coherent content from text, because it knows everything that's been published. And while that may not be 100% true, it's easier just to sort of understand it as it has been trained on every published work there is, text-based. The pre-trained is just that, right? So we have given it this corpus of data, sort of a library of data, and it knows it well. And then the transformer component comes in, and it's able to separate our input from the output, and that's what we're really interacting with. So this gets back to ChatGPT. So we all know and love ChatGPT. Maybe we don't love it as much. Sometimes it can be frustrating. But some things to understand about ChatGPT. So it's based on the GPT architecture, which was actually originally developed out of Google. They wrote the first white paper on the transformer models. So you would think Google would have a leg up, but it's been pre-trained on a diverse data set. It's been fine-tuned for conversations, meaning that it's been instructed that this is going to be a conversation with the user. You're the user, so it keeps the conversation going. That's one of the reasons that agents like ChatGPT do something called hallucinate, where they just make stuff up, because they've been told that they have to be in a conversation with you. And so rather than saying, I don't know, they just continue the conversation. That they're getting better about that, but in the early days, that was a big problem. And it learns and adapts, right? So you can actually teach ChatGPT or Claude or Gemini and whatnot. You can teach it things, and effectively train it in small ways. But one important thing is to remember that ChatGPT is just one of many different AI tools. And so here is an eye chart, and I don't expect anyone to write all this down, and this is 4 months old, 5 months old, so maybe this pie is doubled in size by now. It's hard to say, but there's an immense amount of AI tools out there for people to use. Everything from voice cloning. So the video that you saw of me at the very beginning had there was two tools I used to create that. I used something called 11 Labs, which is a voice cloning tool. They do a great job with voice. So you can train it in your own voice so it sounds like me. And then I used another tool called HeyGen, HeyGen, and that's a tool that allows me to take videos and it creates these digital avatars. And so for those of us who are in sales and want to deliver personalized videos, those are two good tools, but they're one of hundreds of different AI tools in every different capacity. Even when I would argue AI is not needed, there's still an AI tool for it. And yeah, I think we're all we all see a lot of AI being jammed into things where you may not feel that AI was needed, but there it is anyway. So I'll switch over to sort of the economics of AI, because I think that the question comes up a lot when I give this talk, or when we're talking at our meetups about sort of the I'll call it the sort of the apocalyptic view of AI, right? That AI is going to sort of destroy something, economy, society, something. Jobs certainly is the number one topic. So I think it's important to understand sort of what's being predicted of AI. So these numbers are all relevant as of last week. So they may change, but as of last week, that these were correct. So Bain & Company, the big consulting firm, recently released a study last week that said that AI was going to have an addressable market of $1 trillion. But this is the key. The $1 trillion by 2027. So not far off. This isn't a study that says, that this industry is going to be worth $1 trillion by 2040 or 2038 or something like that. We're talking about a couple of years. It's a tremendous number in a very, very short period of time. So, and I think some of this might just be feel like common sense. We're seeing a lot of big numbers being thrown around. OpenAI just raised $6.5 billion on a valuation of $157 billion, making it the most highly valued startup there is right now. But that's because everyone's chasing this $1 trillion number, and everyone believes that to be true. By 2035, a little longer out, it's expected that the manufacturing sector will see the largest financial impact from AI, projected to be about $3.5 trillion. So AI has the potential to contribute a lot to different sectors, and we're going to go into that in the next slide. AI is expected to contribute 21%, a 21% net increase to the U.S. GDP by 2030. So 1/5, we will increase our GDP by 1/5 by 2030. So basically within 5 years, which I don't know that anything else has had that same economic impact, particularly for this country. So it's a really, really important thing to look at. And right now we're already seeing 25% of companies are adopting AI to address labor shortages. And so this sort of leads to the question, like, well, what's going to happen now? Is AI going to take everyone's job? And I think that the answer that I have settled on and that I've discussed at length with others is that I think AI is not necessarily going to take people's jobs. It may prevent new openings at companies where, for instance, at my company, we have AI do our social media. So I have not hired I have not opened a rec for a new social media manager for that. So while AI didn't replace a person, it prevented me from hiring another person, or allowed me to not hire another person. And so that's what I think is going to happen. But we're already seeing it where companies are using AI to fill labor shortages of some kind. This is the slide. These are the numbers that I think most people get worried about, which is job displacement and job creation. But most people don't talk about job creation. Most of it is on job displacement. And so, again, these are from a number of studies. I cited them at the bottom, but the idea that AI could displace the equivalent of 300 million full-time jobs globally. It's a big number. 300 million is a huge number. By 2030, activities accounting for up to 30% of hours currently worked across the U.S. could be automated. So basically, 30% of our standard 40-hour work week could be fully automated. So you can look at this in two ways. One, that's a competitive threat to us as humans and production machines, or it could just give us more time to do other things, right? I really wouldn't mind something that did 30% of my job and allowed me to not have to pay attention to it. And I think that a lot of people who are incorporating AI into their lives, in their businesses, are seeing that as freeing up time, right? It's a huge time saver depending on what the occupation is. On the green side, so we're going to leave the red side. On the green side, these are the numbers that I think are more appealing. So the World Economic Forum estimates AI will create 97 million new jobs globally, and that AI technology is projected to create 12 million more jobs than it replaces. So in effect, a net gain from AI, not a net loss. And so what I think is important about this slide is that the picture that this paints is one of transformation, not of it's a transition into something new. It's going to happen over a little bit of time, but it's going to come pretty quickly. But it's not going to be an overnight thing. It's not going to be one day we all wake up and we don't have a job because AI has taken our job. I think that this is going to be something that gets incorporated slowly, probably picks up speed, and it's going to come in very specialized ways, right? So there are certain things that AI is particularly good at. I'm the CEO of my other company, and recently there was a report that said that they came out from I think University of Washington published a study that said that AI was better than a majority of corporate CEOs at running the business. The only area that it fell down, that it didn't perform well, was in difficult human interactions, which gave me a lot of joy, because as a CEO, most of my job as a CEO is dealing with difficult human interactions. Where AI excels is doing things like strategy work. And so I think that the jobs that get displaced are the ones that are deal with a lot of repetitive tasks. But there is one caveat to this, and that's this note down at the bottom. Educated white-collar workers earning up to $80,000 a year are among the most likely to be affected. So that's a very big departure from previous technology innovations and who is affected. So in most cases, innovation has benefited the higher-end salaried white-collar workers. This is the first time that group is being affected disproportionately. So it's something certainly to keep track of. I want to talk a little bit about where the jobs are and what's predicted. Again, these are all coming from studies, but where we're likely to see things that for good or bad. And so in no particular order, we see automotive manufacturing. So we're already starting to see more and more automation. the big port strike that was luckily lasted just a little while. One of the big topics besides salary was on port automation, and that's still a topic. They just simply punted that, so they still have to deal with that. And aerospace and defense, food processing, we're going to see, I think, a lot of things. There's a lot of repetitive tasks in food processing. The chemical industry is going to benefit, is expected to benefit greatly from AI. AI is extremely good at developing new chemical compounds. This is happening on a sort of daily and weekly basis. So the chemical industry at large is going to benefit. Rather than read this, I think the one area, and this is probably good for all of us, we're all in an area where tourism is a very brings in a lot of our revenue. It's really hard for AI to automate that, right? This is like that is the definition of human interactions, and so it's very hard to create virtual reality beaches over the real thing. So. What comes next? So I put this slide in here with a little bit of a joke. If I knew what came next, I would be on a yacht somewhere, I think. But I think we can all sort of look at this and with a bit of common sense. So I think there are areas where we're going to see a lot more AI, education. We're going to see more growth in the generative AI, the consumer side that we all use. I think we're going to see AI be integrated into everyday activities. This slide was built before Apple Intelligence was released, so now Apple's baking this into the core of their product. When we get into things like quantum computing and AI, when we mesh those two things, it creates a very, very powerful thing, particularly around cybersecurity, around climate change and modeling, and which. From yesterday, we're seeing the effects of, and healthcare. So AI is doing a tremendous job at coming up with novel cures to things, and I think that's just going to explode. I think we're at the precipice of a huge change in that. And with that, I want to say thank you very much for partaking in this and listening to this. I hope this says thank you in all these languages. AI came up with that, and so I hope it's not hallucinating. But that is it for me. I hope I'm good on time. And I think we have a couple minutes left, so if anyone has questions, just please let me know.
Kai, I have a question. This is George. In my
Sure.
earlier presentation, I mentioned earlier about that this 3 Mile Island is actually being started back up.
Yes.
It's a nuclear power plant, but one of the interesting things is that Google and some of the others are trying to buy it to power their data centers. How does AI fit into that whole thing? Why do you need a nuclear power plant to power AI?
So 3 Mile Island, which was in operation until 2019. So it's not like it had ever it was only shut down for a shorter amount of time. Microsoft is actually the one who is going to. They are contracted to purchase all of the power from one reactor. They're gonna fire up one reactor in 3 Mile Island. I think it's Continental Energy is going to run it. It's going to cost $2 billion to get that back and operational, and 100% of the power is going to Microsoft for their AI data centers. And so I think that it's a great question, George, because AI consumes a massive amount of electricity, of energy. And so now you have lots of data centers that are being built just for that. And right now so Microsoft AI, their purchase of 3 Mile Island it's generating enough power to power 700,000 homes, but it's actually going to go just to Microsoft data centers. In XAI, which is Grok, Elon Musk's AI company. They're running into an issue right now with power because they're trying to build a very large data center in Memphis. They actually have already built it, but it's taking so much power that they're running into power issues in Memphis, and so there's been a sort of a public outcry, and I imagine we're going to have more of those as this happens, because the AI is not slowing down, and I don't think that the energy efficient chips are coming online fast enough. So we just have to. I think all the big companies are now investing a lot in nuclear as a carbon free, highly resilient power source. It'll be very interesting to see how that all shapes up.
All right. Thank you, Kai.
You got
Are
it.
there any other questions? Tamika, you can, yeah, thank you, Kai. Appreciate that.
Very welcome.
Questions for Kai, everyone.
Okay, wonderful, wonderful. So right now, I don't see any questions. That doesn't mean that they won't pop up in the next minute or so. But
Sure.
definitely, Kai, that was fantastic. They say that, fear stems from the lack of knowledge. And
Yes.
honestly, like when everybody started talking about AI just a few short years ago, I was definitely starting to panic, growing up with, like I said, sci-fi
Yeah.
in the 90s. But hearing professionals like you really just say, hey, listen, relax. This is how you can benefit from it. These are the wonderful things you can do with it. I feel so much better, and I'm excited.
Well, I say, and I mean this, I really feel like the future is going to be sort of two groups. There's going to be the group that understands AI and is able to use it, and then the other group's going to work for the first group.
Yes, and I want to be on the right side of things.
That's right. That's right.
Sharing your vision and your passion with us is highly appreciated.
Of course, my pleasure.
Thank you.